All right, so the last section was the hardest section that we do. I think this section is one of the two easiest that we do, not to mention it's only 5 questions long. So what we're going to do is mess with inverses and their derivatives. Okay, so theoretically, you already did the Chapter 5 algebra review before we started Chapter 5. But that being said, is if f of x equals y. Okay, so I shove in an x value into my function, it spits out a y value. On the inverse, the point y equals x, f of y equals x will be on the inverse. Okay, so the x's and the y's flip-flop. So if you think about that, if on a function the slope is defined as the change in y over the change in x, then on the inverse, you'll just invert that. And so the change in x over the change in y would be the slope of the inverse. So we're going to do a little bit of calculus. And again, I'm going to change up the order of all 5 of these problems. We're going to start with number 3. So number 3 says, if I am given a function, f of x, and that equals x plus a to the third plus b, where a and b are numbers. Okay, so first of all, what does this mean? This means it's a cubic function. If I add a number here, that just shifts it up and down. If I add a number here, it shifts it left and right. So bottom line is that this is a cubic function that may or may not have been moved, but it has not been flipped, it has not been stretched, it has not been compressed. So what do we know? I know if I take a derivative, that's going to give me a 3 times x plus a squared, and then the derivative of the inside is 1. Okay, what does this mean? That means I have a cubic function. Okay, so he looks somewhat like this unless I move him. Well, what does your derivative look like? Your derivative is going to look like a parabola. Okay, so what does this mean? Okay, that means for any value I shove in for a, shove in for x, what am I going to do to that value? I'm going to square it. Okay, so if I shove in something here and I get a negative and I square it, what's it going to do? It's going to go positive. Times 3 is positive. If I shove in a positive, that means I'm going to add whatever this is to it, square it, get positive, times 3 is positive. Back in college algebra, you did a horizontal line test to determine if this function right here had an inverse function. Well, now what we can test for is, it's called monotonic, mono meaning one direction, or the monotonicity, okay, of the function. So what does this mean? That means when I look at the derivative, all the slopes are positive, okay? So it is forever increasing. That's what that means, which means it's a different way to determine if this thing has an inverse function or not. So since the derivative, when you evaluate it, will always be either positive or always be negative, in our particular case, it's always positive, that means it's monotonic, okay? So this is strictly monotonic, and therefore it does have an inverse function. Okay, so let me give you an example where it wouldn't work. So let's pretend like we start with a parabola. Okay, if I take that thing's derivative, I get a 2x. Okay, so if I shove in negatives, I'll get a negative slope. If I shove in positives, I'll get a positive slope. So the slopes change signs. So he is not strictly monotonic. So that's what that means. So that was number 3. So what does that mean? Well, let's go and look at number 2 next. So number 2 simply says, if I am given a function, and I'm not given the formula for it, I'm just given the function. If the slope of the tangent line to the graph of the inverse, okay, so on the original function, this point must have already flipped. So the original function must be at negative 1 comma negative 1/2, okay? Well, looky over here. I've got a point at negative 1 comma negative 1/2. This is the original function. What is the slope of my original function? What's the slope of its tangent line at this point? Its slope is 1/2. Okay, well, if I'm dealing with the inverse, and if I flip-flop my x's and y's, then what is the slope of the inverse function at the inverse? It's going to be flip-flop your x's and y's. So it's going to be a 2/1 or a 2. Okay, 2 over 1 reduces to 2. So notice I just flip-flop the location of my x's and y's. So again, look at this one. At the inverse, I've got the 0.12, which means on the original function, I've got the 0.21. Well, if the inverse, or if the original function has a slope of 2 at that tangent line, so if this has a slope of 2, well, what must the slope of the inverse be at that point? Well, it must be, flip-flop your x's and y's, it must be 1/2. Okay, that's all you're doing is you're flip-flopping your x's and y's. So we've done number 2, we've done number 3. We are going to do, let's go ahead and do number 5, because it looks scary, but it's not. It says find dy dx for the equation at the given point. So I am given x equals, and then I'm told y to the third, and I'm told, hang on, minus 8y squared plus 1. Minus 8y squared plus 1 at the point -6, comma 1. Okay, so it wants me to find dy dx. So what's the slope of x? It is 1 dx. I said slope. What's the derivative? Sorry. What's the derivative of y cubed? It is 3y squared dy. What is the slope of, what's the derivative of -8y squared? It is -16y dy. And then what's the derivative of 1 is 0. Okay, so I want to solve for dy dx. So I'm going to divide everything by dx. So that gives me 1 equals 3y squared dy dx minus 16y dy dx. Well, now I can factor out a dy dx. So 1 equals 3y squared minus 16y dy dx. And now I can divide both sides by the 3y squared minus 16y. So I get 1 over 3y squared minus 16y is my value for dy dx. Well, what value do I want to evaluate this thing at? Remember, you haven't flip-flopped anything. This is still an x and this is still a y. So what's your y value that you're going to evaluate at? It's going to be 1. So I get 1 over 3 times 1 minus 16 is going to be a -13. So your slope is a -13. Or sorry, good, my mouth, is a -1 over 13. That is what the value for dy dx is. So now for the last two, we're going to have to get a little bit more exciting. And these last two, I am given for number 1. I am told that my original function is x to the third plus 4x minus 1. And I'm told that a equals -6. And I am trying to find the inverse derivative at -6. Okay, so what is the derivative of the inverse evaluated at -6? Now, instead of us diving in and getting lost in algebra world, we're going to make this very easy. So normally, what variable would be right here? Normally we see f of x, g of x, h of x, whatever. But notice that we're dealing with the inverse. So this is actually, I have flip-flopped because I'm dealing with the inverse. So this is the x value on my inverse. Well, what does that mean for my original function? It means it was the y value on my original function. Okay, so they've given me the y value on my original function. So if I look at it this way, that means I've got x to the third plus 4x minus 1 equals -6. Okay, so I'm going to add 6 to both sides. So I get x to the third plus 4x plus 5 equals 0. Now, from here, this is not quadratic, so don't do that. What you have is if I graph this thing, so x to the third, and then plus 4x plus 5. If I graph it, I want to find out where this thing hits the x-axis. And that's going to tell me the corresponding y value that I can use for this. All right, so it's not going to make sense yet. Hang on. So it hits at -1. You can see that and you can prove it. So if I hit, what is the value? At an x value of -1, I get 0. Okay, so here's what you just found out. On my original function, the point -1, -6 exists. Okay, on my inverse function, I would flip-flop my x's and y's. So the inverse is not easily found in algebra here. So what we're going to do is we're going to do the easy way, and I'm going to find the slope of the original function at my given point, and then I'm going to flip it. That's all I'm going to do. I'm going to find the slope of the original function at the given point, and then I'm going to flip it. So this is the x and the y on my original function. So take the derivative of your original, which is a 3x squared plus 4, and evaluate it at the x value you just found. Okay? Evaluate it at -1. Okay? So -1 squared is 1 times 3 plus 4 is 7. I just found a value of 7 evaluated at the x coordinate I found. Okay, well, if on my original function, my derivative would evaluate at 7 over 1, what will evaluate it at the inverse? Flip it, and it will flip it 1 over 7. Okay, so what did we just do? Let's rinse and repeat because we've only got one more problem to do on this section. They gave me a y value. I used my calculator to find the x value. Okay, so take a derivative, evaluate it at that x value. I got a 7 over a 1. So if on the original function at -1 comma -6, I have a slope of 7. That means on the inverse function at the point -6, -1, I'll have a slope of 1/7. Okay, so let's do this again. We have one more problem, and that is going to be number 4. So this said, oh no, that says I have, and it's going to be the same thing. They're going to give me a y value. So I've got to figure out what's going on. So I have f of x equals x to the third minus 1, and I'm supposed to find the derivative of the inverse. Okay, so the derivative of the inverse is what? Evaluated at 7. So in this case, my a is 7. So what do? I don't want to find a whole bunch of inverses and derivatives and all that kind of mess. So what I want to do is go ahead and solve this thing. So if this is the x value in my inverse, it must be the y value on the original. So on the original, I'll set it equal to 7, which means now I'm going to subtract. So I get x to the third minus 8 is 0. When you graph that, so x to the third minus 8, and then delete the rest of this crap off. When you do this, you're going to find out it hits the axis at 2. Okay, well, there it is. All right, so what do I know? I know that x is 2. So on my original function, I have the point 2 comma 7. On my inverse function, I have the point 7 comma 2. But I'm just going to stay and work with the original function. So now take the derivative of your original function, which is 3x squared. Evaluate it on that graph, which means I'm going to shove in a 2. So I get 3 times 2 squared is 12. Well, if on the original function at the point 2, 7, my slope is 2, then on the inverse at the point 7 comma 2, my inverse must be flip it. So I get 1/12, and that's your answer. And that, my friends, is 5.3. Move. It won't move. Okay, sorry.